Convoy H-X-two-twenty-eight sailed under attack alert. At 11:43 hours, HMS Fame maintained ASDIC contact on a submerged target 900 yards ahead. Instead of dropping depth charges astern, her commander ordered a single forward salvo of 24 small bombs. The sea absorbed them silently, until one sharp crack broke the surface calm. The sonar echo vanished. Oil spread in the waves. The new forward-throwing mortar, Hedgehog, used 24 contact-fused projectiles hurled ahead of the ship. A miss remained silent. A hit destroyed. In 1942, it took 80 depth-charge attacks to sink one U-boat. By 1944, Hedgehog reduced that to 1 in 10. This statistical inversion marked a decisive shift in anti-submarine warfare, when silence became deadlier than noise. A contact plot chalked on a bridge bulkhead tracked a submarine echo that flickered off the scope each time the escort charged in to drop. Grease pencil lines marked the predicted path. Officers stared at the plotting table, watching the contact fade precisely when they needed it most. Escort doctrine required the attacker to pass directly over the submerged target, which temporarily blanked ASDIC. The U-boat had a warning: propeller noise rising, hull vibration increasing, and time to change depth or heading. Operational summaries from Western approaches showed success per attack around 1 to 2% in the worst months of 1942, while convoy tonnage losses peaked. Captain Frederick John Walker, commanding the 36th Escort Group, recorded the central paradox in Admiralty Report SW/25/42. "We are deaf the moment we fire. Depth charges, typically 300-pound class with hydrostatic fuses, were set to detonate at predicted depths, not actual target position. Escorts released patterns in formations called ladders, diamonds, or curtains to increase probability, but the explosions themselves masked sonar returns for precious seconds and often forced a re-attack cycle. The mismatch between sensor and weapon, continuous tracking required versus contact loss to deliver ordnance, produced low kill ratios, high ammunition expenditure, and long engagement times that jeopardized convoy spacing and maneuver freedom. A Western Approaches Operations Digest from mid-1942 recorded, "Multiple barges yielded negative evidence. Oil sightings unconfirmed. Contact reacquired after 3 minutes 30 seconds. In the first 6 months of 1942, Allied convoys lost hundreds of thousands of tons monthly. Germany launched an average of 20 new U-boats each month. The industrial capacity of the Reich was turning out submarines faster than Allied escorts could sink them. In June 1942 alone, convoy losses reached 700,000 tons of shipping. British escorts reportedly expended 14,000 depth charges that month for 11 confirmed sinkings, a ratio that implied the weapon, not the crews, was the limiting factor. A test memorandum laid on a drafting table showed spigot-mounted projectors, contact fuse sensitivity notes, and pattern geometry sketches. Engineers gathered around the paper, debating propellant loads and impact angles. The expectation in 1940 through 41 favored heavier charges and larger patterns. The DMWD proposal pursued the opposite. Smaller individual bombs, fired ahead into the sonar contact zone, detonating only if they struck the target. Charles F. Gedive of the Royal Naval Volunteer Reserve coordinated development. Lieutenant A.H. Ball and staff engineers documented fuse trials at the proving grounds. They tested impact sensitivity on steel plates representing submarine pressure hulls. The prototype Hedgehog anti-submarine projector, later designated Mark 10, consisted of 24 spigots arranged in a circular crown pattern. Each salvo weighed approximately 24 times 65 pounds, total projectile weight around 1,560 pounds. Each bomb carried 30 to 35 pounds of Torpex high explosive filling. Nominal range reached 200 to 250 yards. The pattern footprint measured 100 to 140 feet in diameter. The contact fuse, designated number 845 type, prevented water column detonations. This was revolutionary. Traditional depth charges exploded whether they hit the submarine or not, creating massive noise that saturated sonar receivers for minutes. Hedgehog bombs detonated only on direct contact with a solid object, the submarine hull itself. Single-operator electrical firing aligned with the sonar solution. Ballistic tables were tuned so the bombs entered the water near simultaneously, maximizing instantaneous contact probability across the footprint. A DMWD note from late 1941 stated the objective plainly: preserve ASDIC contact through the run-in and attack. Avoid hydrostatic explosions that saturate receivers. Contact-only detonation kept the water quiet during misses, enabling immediate reacquisition and rapid repeat salvos. The design solved the sensor weapon coherence problem. The escort could continue seeing the target while striking it. Bench tests recorded hull plate rupture thresholds achievable with a direct hit Torpex charge. Early tank trials against representative steel plates showed destructive overpressures on contact. Engineers calculated that a single 65-pound bomb detonating within 25 feet of a submarine's pressure hull would rupture 3/4-inch plating. The physics were elegant. Instead of trying to crush a submarine with water pressure from a nearby explosion, Hedgehog delivered a shaped charge directly against the hull. The difference between near-miss and hit was the difference between survival and catastrophic failure. As the prototype stabilized in late 1941, U-boat commissioning accelerated across German shipyards. Kiel, Hamburg, and Bremen turned out new boats at increasing rates. The race had begun, turning precision, not mass, into the only affordable answer for escorts outnumbered at sea. A moored target hulk sat at controlled depth in Portsmouth Harbor. Stopwatch, plotting board, and recorder stood by as the first pattern entered the water. Test officers watched from the escort's bridge. Traditional trials of depth charges often recorded probables based on oil slicks or air bubbles rising to the surface. Hedgehog trials produced clear binary evidence: silence for a miss, a single sharp detonation on contact. A series of live exercises returned 5 direct hits in 14 firings against instrumented targets. This represented an order of magnitude improvement over baseline depth charge expectations in comparable geometry. The math was undeniable. A 5 in 14 success rate translated to roughly 36%, compared to the 1 to 2% achieved by depth charges in 1942 operational conditions. Rear Admiral A.C. Collins reviewed the trial data and wrote in Trial Memorandum A/S321/42. The absence of noise was itself a weapon. The silence meant more than avoiding sonar disruption. It meant psychological advantage. When depth charges exploded, U-boat crews knew they were under attack and could take evasive action during the sonar blackout. With Hedgehog, a miss gave no warning. The submarine crew had no indication of danger until the moment of impact, if impact came at all. The Admiralty standardized the mount and issued orders for fleet installation. The official designation Hedgehog anti-submarine projector Mark 10 entered outfit lists for destroyers, escort destroyers, corvettes, and frigates. Shipyards received wiring diagrams and deck strength plans that allowed 48-hour fitment during turnarounds. Installation was remarkably straightforward. The launcher weighed approximately 3 tons and required reinforced deck plating plus electrical connections to the ship's fire control system. No major structural modifications were necessary. An escort arriving for refit could receive a Hedgehog installation and be back at sea within 2 days. The move from test bed to fleet shifted convoy defense from area bombardment to contact probability tactics. Training syllabi at Londonderry and other anti-submarine warfare schools added the hold fire reacquire doctrine, synchronizing sonar plot, helm, and firing key within a 50 to 60-second cycle. Instructors drilled crews on approach geometry. The key was maintaining steady ASDIC contact while maneuvering the ship to place the pattern where the submarine would be, not where it had been. This required accounting for target motion, ship motion, and water conditions. By early 1943, the first production units reached operational escort groups in the North Atlantic. Crews trained intensively on dummy runs before facing real contacts. The weapon's simplicity aided adoption: 1 operator, 1 firing key, clear visual confirmation of pattern entry. 6 months after the Portsmouth trials, the first North Atlantic kill by a forward-throwing mortar would confirm the trial data under wartime conditions. The proving ground had delivered its verdict. Now the Atlantic would deliver its own. Production ledger entries tallied launcher frames by week. Fused lots passed inspection in long rows. Cases of Torpex were allocated and logged in ordnance manifests. Pre-Hedgehog thinking equated protection with heavy steel and large charges. Hedgehog's value was cost-effective probability. Modest warheads multiplied by pattern geometry and accurate placement. Royal Ordnance Factory Woolwich scaled output into the low thousands for launchers. United States partners, including Bethlehem-linked fabrication shops and Navy yards on both coasts, produced additional mounts, spares, and bombs under Lend-Lease agreements. Unit cost for a launcher was approximately £2,000 sterling, a small fraction of a medium gun mount. Installation time of 48 hours contrasted with weeks required for major anti-submarine warfare refits. Standard ship allowance called for 150 to 200 bombs carried aboard, replenished during convoy turnarounds in port. Ballistic calibration and fuse proofing ran alongside depth charge production so escorts could employ mixed tactics based on contact quality and engagement geometry. A British ordnance planning paper from early 1943 prioritized distribution. Launcher priority goes to North Atlantic escort groups. Mediterranean and Arctic routes follow as fittings permit. High launcher throughput relative to ship availability allowed rapid doctrinal standardization across key escort classes. The marginal cost per attack dropped significantly. More attacks could be carried out per contact with less sonar disruption, reducing ammunition consumption and increasing tactical flexibility. By mid-1943, Britain had produced 1,400 Hedgehog launchers. United States yards added another 800. Total bomb production reached 620,000 rounds by war's end. Each bomb represented a precisely manufactured fuse, a machined steel casing, and carefully loaded Torpex explosive. Quality control was essential for contact reliability. Training schools reported crews reducing attack latency, the time from firm contact to firing, to under 1 minute. A quiet miss allowed near-instant reattack, decreasing total engagement time and freeing escorts sooner to reform protective screens around merchant convoys. The production numbers told a strategic story. For every ton of Torpex packed into Hedgehog bombs, statistical analysis suggested 3 tons of merchant shipping were saved from submarine attack. The return on investment was measurable and dramatic. Logistics officers calculated that a single Hedgehog salvo, 24 bombs totaling 1,560 pounds of projectiles, cost approximately £35 sterling in materials and manufacturing. A depth charge pattern of 10 charges cost substantially more and delivered far lower probability of kill. The cost-effectiveness curve favored forward-throwing mortars by a wide margin. By mid-year 1943, the number of escorts sailing with at least one forward mortar ceased to be an exception. It became a convoy standard. Production had scaled to match operational demand. The factories of silence were running at full capacity. A contact designated Red 5 held steady on the plot as sea state rose. HMS Fame maintained ASDIC lock at 900 yards. The commander gave the order. The firing key closed. The old pattern would have been a heavy ladder of depth charges dropped astern with uncertain evidence of effect. The Hedgehog attack gave either nothing or a precise detonation. HMS Fame's salvo produced 2 underwater detonations. The sharp cracks echoed across the convoy. Debris and oil appeared on the surface minutes later. Admiralty signals identified the target as U-353, commanded by Oberleutnant Wolfgang Rosenbaum. All 48 crew perished. Commander W. D. Smith recorded the action in his official report. No pattern thunder. A single crack. Echo absent. Oil observed. The contact-only principle eliminated the masking period that previously forced escorts to circle back blind. Attack procedures were immediately updated across Western Approaches Command to privilege a forward salvo on steady, short-range contacts before considering any astern depth charge pattern. The kill was not luck. It was geometry, probability, and engineering. Fame had maintained continuous sonar contact throughout the attack run. The pattern entered the water ahead of the ship. The U-boat, maneuvering to evade, moved directly into the pattern footprint. 2 bombs struck the pressure hull. 1 detonation was sufficient. Within 48 hours, a second contact in the convoy's protective orbit fell to a similar forward-throwing attack. This second kill, achieved by another escort in the same group, confirmed that the March 17th success was not an anomaly. The weapon worked as designed under operational conditions. Word spread through Western Approach's command headquarters in Liverpool. Signal traffic increased as captains requested Hedgehog installation and training priority. The quiet ring of projectiles on the forecastle, 24 spigots arranged in a crown, could do what tons of conventional depth charges often could not. The psychological impact on escort crews was immediate. For years they had prosecuted attacks with limited feedback, explosions, then waiting, then hoping for oil or debris. Hedgehog gave binary clarity. Silence meant miss and immediate reattack. Detonation meant confirmed hit. U-boat survivors recovered from other actions later described the weapon in interrogations. One submariner stated, "There was no warning cascade of explosions, just sudden impact and flooding. The first operational kills validated years of development work." The Directorate of Miscellaneous Weapons Development's unorthodox approach, small bombs, contact fuses, forward throw, silent misses, had been proven in combat. The theoretical kill probability curves matched observed results. Admiralty Signal CX-2124 formally confirmed the kills and distributed tactical lessons learned. Escorts were instructed to favor Hedgehog on any firm, short-range contact where maneuver room permitted a steady approach. The weapon was no longer experimental. It was operational doctrine. An instructor at the anti-submarine warfare school pointed to a chart mounted on the classroom wall. Attacks, kills, and success rates by weapon type filled the columns. Students leaned forward, studying the numbers. 1942 attack-to-kill ratios with depth charges had been discouraging. By late 1943, Hedgehog engagements showed multiple-fold improvements in confirmed sinkings per attempt. Aggregated returns from escort groups indicated success rates for Hedgehog that rose into the mid-single digits, and then low double digits as crews mastered run-in geometry and reattack discipline. A representative comparison for 1943 showed depth charge attacks numbering in the thousands for scores of kills, approximately 1 to 2% success rate. Hedgehog attacks numbered in the hundreds for dozens of kills, approximately 6 to 12% success rate, with significant variation across theaters and tactical conditions. The Anti-Submarine Warfare School in Londonderry revised its syllabus in autumn 1943. The new doctrine stated, "Adopt hold fire reacquire loop. Reattack immediately if no detonation. Do not surrender contact to area charges unless contact degrades below firing solution quality." Crews learned to adjust ship speed and helm to project the pattern where the echo would be, accounting for target motion and thermoclines. Quiet misses conserved ammunition and preserved contact history, improving cumulative probability across sequential salvos. A detailed statistical study showed that first salvo kill probability ranged from 5 to 15% depending on contact quality, sea state, and crew proficiency. Second salvo probability, when fired within 90 seconds of the first, increased significantly because the submarine was still within the same water volume and had limited evasive options. The measured improvement shifted resource allocation across the Royal Navy. Escorts prioritized Hedgehog installation over some secondary gun upgrades. Training time moved from depth-setting calculations to approach geometry and fuse reliability checks. Operational after-action reports documented engagement timelines. The average time from initial contact to confirmed kill dropped from over 15 minutes with depth charges to under 5 minutes with Hedgehog. This compression of the engagement timeline had strategic implications. Escorts could prosecute contacts faster and return to convoy screening stations sooner. Ammunition expenditure per kill also declined dramatically. Traditional depth charge attacks might expend 50 to 100 charges per confirmed sinking. Hedgehog attacks averaged fewer than 10 salvos, fewer than 240 bombs, per kill. Given production constraints and logistics, this efficiency multiplied available combat power. By autumn 1943, escort captains submitted formal requests through command channels to add a second launcher or stabilize existing mounts for better performance in rough seas. These requests represented administrative proof that the weapon had become central to anti-submarine warfare operations, not supplemental. The numbers rewrote doctrine because they were undeniable. In naval warfare, where resources are finite and every ship matters, a 5-fold improvement in kill efficiency changed the strategic calculus. The Atlantic battle was being won one quiet salvo at a time. A technical sketch on a Befehlshaber der U-boot desk showed a Hedgehog bomb cross-section. Margin notes in German script queried fuse sensitivity and pattern density. Intelligence officers studied captured fragments. German countermeasures for depth charges, rapid dives, knuckles created by sharp turns, bubble decoys called Pillenwerfer, and listening for approach patterns had some value against preset depth detonations. They faltered against a silent, contact-only strike delivered while the attacker maintained continuous sonar lock. BDU directives in late 1943 warned about the new English weapon that detonated on impact rather than at preset depth. Technical analysis recognized that evasion windows were too short when the escort never lost contact. Traditional evasion tactics assumed a sonar blackout period during the attack time to dive deeper, change course, or deploy decoys. The Hedgehog eliminated that window. A U-boat commander's post-action remark appeared in war diary extracts later captured and translated. There is no warning. One moment the sea is quiet, the next the hull opens. The comment appeared in interrogation files documenting U-852 operations. Attempts to spoof Hedgehog with noise generators or air released from canisters offered little protection. Because misses generated no blasts, there was no masking effect and no acoustic cue for the submarine to change tactics. The crew had no way to know an attack was in progress until impact occurred. German naval engineers proposed several countermeasures. Thicker hull plating was rejected due to weight and construction time penalties. Improved hydrophones to detect the projectiles entering the water showed limited effectiveness. The time between detection and impact was measured in seconds, insufficient for meaningful evasive action. Decoy devices proved useless because the weapon required direct contact to detonate. One proposal suggested spraying chemical compounds to create false sonar returns, but testing showed the materials affected sonar performance equally for both attacker and target. Another suggested rapid depth changes during the final seconds of an attack run, but this required knowing an attack was incoming, precisely the information Hedgehog denied. As countermeasures lagged, the risk calculus shifted. The U-boat faced increasing probability of sudden destruction per attack. The consequence was statistical. More boats failed to return in peak months, constraining wolfpack operations and reducing the effective submarine force available for convoy interception. In one late summer tally from August 1943, U-boat losses reached 19 boats, a record level for a single month. While multiple factors contributed, improved radar, HFDF direction finding, increased air cover, and code breaking, the rapid spread of forward-throwing mortars with contact fuses featured prominently in operational analysis. The German response was ultimately strategic rather than tactical. Unable to counter the weapon effectively, BDU shifted patrol areas and reduced concentration in the North Atlantic gaps where Allied escort density and Hedgehog availability were highest. This strategic withdrawal marked a turning point in the Atlantic campaign. A printed attack sheet clipped to a plotting board listed required elements: bearing, target speed, ship speed, fire solution, reacquire order. Escort crews consulted these sheets during training and operations. Old attack cycles ran 3 minutes or longer from initial contact to first explosions. Standardized Hedgehog drills cut engagement time under 1 minute with no sonar blackout period. Escort Group 2, commanded by Captain Frederick John Walker aboard HMS Starling and consorts, reported double-digit confirmed kills over 12 months. Most were attributed to forward-throwing attacks using disciplined hold-fire-reacquire doctrine. Other groups operating in the North Atlantic and Bay of Biscay reported compressed engagement timelines and fewer reattack legs required per kill. Crews adopted creeping approaches at optimal speeds to stabilize the contact bearing. Some ships added gyroscopic compensation equipment to improve pattern placement in heavy sea states. The integration of technologies, radar and HFDF for initial detection and interception, sonar plus Hedgehog for the kill chain, created a layered defense that was greater than the sum of its parts. Tactical manuals were amended with new procedures. The updated instructions read, if no detonation and contact persists, repeat salvo immediately from adjusted bearing. Avoid wasteful astern patterns except to finish a damaged target confirmed by debris or survivors. The synchronized sensor weapon cycle restored tactical initiative to escorts. Previously, submarines could exploit the sonar blackout to escape. Now, continuous contact meant continuous threat. This pressure affected U-boat operational behavior. Boats spent less time on the surface charging batteries, reduced pursuit time against convoys, and broke off attacks more readily under marginal conditions. Convoy formations benefited directly. With faster prosecution of submarine contacts, convoys could maintain formation without prolonged evasive zigzags. This reduced merchant exposure time in danger areas and improved logistics. Ships arrived on schedule with less fuel consumption and lower crew fatigue. Training outcomes showed marked improvement in crew confidence. Post-action surveys indicated that knowing whether an attack succeeded or failed immediately, through detonation or silence, reduced stress and improved decision-making during subsequent engagements. The psychological burden of uncertainty was lifted. Statistical analysis of engagements from October 1943 through March 1944 showed consistent patterns. First attack success rates ranged from 8 to 14%. Follow-on attacks within 2 minutes increased cumulative success to 20 to 30%. 3 or more attacks on the same contact pushed cumulative probability above 40% in many documented cases. The new rhythm, quiet approach, silent miss or single lethal crack, became the soundscape of the mid-ocean war. Merchant sailors in convoy reported hearing occasional sharp reports from escort positions, followed by increased radio traffic and sometimes debris recovery operations. The sounds of prolonged depth-charge barrages became less frequent as Hedgehog adoption spread fleet-wide. By spring 1944, the tactical transformation was complete. Forward-throwing mortars with contact fuses had become the primary anti-submarine warfare weapon for close engagements. Depth charges remained aboard for area denial and finishing damaged targets, but the opening attack belonged to Hedgehog. A staff officer at Western Approach's command flipped through pink sheets listing daily situation reports. U-boats sunk, damaged, or missing. The columns are filled with unprecedented numbers. Through 1942, convoy losses suggested Allied defense was barely holding the line. By May 1943, verified U-boat sinkings surged while convoy losses fell sharply. Allied records show more than 40 U-boats destroyed in May alone, the single worst month for the German submarine arm in the entire war. Simultaneously, convoy ship losses declined markedly from spring to early summer. A Kriegsmarine diary entry from Befehlshaber der U-boot headquarters recorded the strategic decision. Withdraw from North Atlantic route. This reaction responded to combined pressures, long-range air cover, HFDF direction finding, improved radar capable of detecting surface submarines at night, and the precision strike capability now available to surface escorts. Hedgehog did not act alone in achieving this result. It completed a technological chain. Detection and localization improvements through radar and radio direction finding raised the odds of finding a submarine. Long-range maritime patrol aircraft closed the mid-Atlantic gap where submarines had previously operated with relative safety. Hedgehog raised the odds of quickly destroying a submarine once located. The cumulative effect shortened U-boat patrol endurance not through fuel limitations or weather, but through survival probabilities. Submarines that once stalked convoys for days now faced immediate lethal threat upon detection. The strategic implication was immediate: disrupted wolfpack concentration and increasing gaps in patrol picket lines. Statistical analysis of May 1943 showed a fundamental shift. For the first time since 1939, the rate of U-boat destruction exceeded the rate of new U-boat commissioning. Germany's submarine force began shrinking in absolute numbers. Convoy loss rates plummeted. March 1943 saw 120 Allied merchant ships sunk. By June, that number fell to 22 ships. The decline continued through summer and autumn. Mid-ocean convoy lanes became statistically safer transit corridors than coastal routes where single submarines could still operate against independent shipping. The human cost of May 1943 fell heavily on U-boat crews. The average age of submariners was 21 years. Loss of 40 boats meant approximately 2,000 men killed or captured, an entire generation of trained submariners lost in 30 days. British and American escort crews noted the change in operational tempo. Contacts that once led to prolonged engagements now resolved within minutes. The psychological pressure shifted from defenders to attackers. Submariners faced increasing probability of detection, decreasing probability of escape, and knowledge that the ocean had become transparent to Allied technology.
Admiral Karl Dönitz faced an impossible situation.
Withdrawing from the North Atlantic conceded the primary strategic objective, interdicting Allied supply lines to Britain. Continuing operations meant unsustainable attrition. He chose withdrawal, hoping to preserve the submarine force for future operations with improved technology. For the first time since the fall of France in 1940, the Atlantic sea lanes were open. The tide had turned, measured in tonnage saved and submarines destroyed. May 1943 marked the climax of the Atlantic battle. A United States Navy test officer signed off on a firing table at the anti-submarine warfare training facility. Range markers stood at 300 yards. Blast gauges were prepared for measurement. The United States Navy moved from adoption to adaptation. Stabilized mounts and the rocket-propelled mousetrap variant suited small destroyer escorts and improved performance in rougher sea states. Pattern dispersion decreased and hit probability improved through these refinements. United States Navy trials measured contact kill probability per salvo approaching the high teens or better in favorable conditions, with double-digit averages reported in training memoranda. Euro-stabilized aiming systems, improved fuse batch quality through manufacturing standardization, and better projectile assembly tolerances lifted performance beyond initial British benchmarks. USS England, designation D635, demonstrated the operational ceiling of the sensor-to-salvo approach. Between May 19 and May 31, 1944, England sank 6 Japanese submarines in 12 days through a repeatable contact prosecution loop. Each attack followed the same pattern: radar or sonar detection, approach to firing position, hedgehog salvo, immediate reattack if no detonation, confirmed kill through debris or breaking up noises. The 6 kills represented statistical improbability turned into operational reality through crew proficiency and weapon reliability. England's success generated fleet-wide attention. Admiral Ernest King remarked, "There will always be an England in the United States Navy." Fleet communications from Commander-in-Chief Pacific and Chief of Naval Operations documented the tactical advantages. One communique stated, "Destroyer escorts employing ahead-throwing projectors achieve rapid neutralization times and reduced ammunition expenditure compared to depth-charge sequences." The United States' contribution extended beyond manufacturing additional launchers. American industrial capacity produced standardized components that improved reliability. Quality control in fuse production reduced dud rates. Training pipelines brought crews to proficiency faster through systematic instruction and realistic exercises. By mid-1944, United States destroyer escorts were being commissioned with Hedgehog or mousetrap installations as standard equipment. The weapon was no longer an addition during refit, it was part of the original design. This integration reflected lessons learned from British experience and American emphasis on mass production of standardized, effective systems. Cost analysis showed dramatic return on investment. A U-boat required national resources to construct: steel, skilled labor, trained crew, diesel fuel, torpedoes, provisions. Construction time exceeded 1 year from keel laying to commissioning. A Hedgehog salvo cost approximately $50 in materials and manufacturing. The economic exchange ratio favored the defender by orders of magnitude. Pacific theater operations validated the weapon against Japanese submarines, which employed different tactics than German U-boats but faced the same vulnerability to direct contact weapons. Japanese submarines, often larger and used for supply runs to isolated garrisons, proved susceptible to the same sensor weapon integration that devastated the U-boat fleet. The refinement process demonstrated American industrial and engineering culture. Adopt proven technology, improve manufacturing, standardize components, train systematically, and deploy at scale. These principles turned Hedgehog from British innovation into Allied standard equipment across 2 oceans. An interrogation report lay open on a desk at an Allied intelligence facility. A translator underlined a German phrase used by multiple prisoners to describe the weapon: Das stumme Ungeheuer, the mute monster. Depth charge attacks, for all their explosive power, had given U-boat crews audible warning and sometimes hope of escape. The characteristic sound of an escort passing overhead, followed by the cascading detonations of a depth charge pattern, provided seconds to take emergency measures. Blow ballast tanks, change depth, turn hard, release decoys. Hedgehog offered neither warning nor hope. The weapon arrived in silence. Interrogation summaries and officer reports recorded prisoner testimony emphasizing shock at an attack with no preparatory explosion curtain. One submariner described the experience. "We heard propeller noise increasing in bearing rate, then nothing, then impact and instant flooding through ruptured frames. Because misses produced no blasts, crews lacked acoustic cues to execute last-second maneuvers. The first indication of danger was hull rupture, by which point survival depended on watertight integrity and damage control, not tactical skill. The psychological dimension of this reversal affected operational behavior across the U-boat fleet. Post-war analysis of patrol reports showed declining aggressiveness in approach tactics starting in late 1943. U-boats that previously spent hours stalking convoys into optimal firing positions now broke off more readily under marginal conditions. Surface stalking time decreased measurably. Submarines required surface running to charge batteries and make transit speed. Time on the surface meant vulnerability to radar detection and air attack. But remaining submerged invited different dangers: slower speed, limited battery endurance, and vulnerability to surface escorts with weapons that didn't warn of their approach. Morale reports filed by German naval intelligence documented increasing psychological strain on crews. Unlike surface combat where threats were visible, submarine warfare required enduring blind terror. Depth charges at least provided audible evidence of the threat. Hedgehog offered only uncertainty. Was that an attack that missed, or were no weapons fired at all? An Admiralty report from the Q-series post-action interrogations included testimony: no warning sound, one detonation. Total systems failure reported by survivors. We never knew the attack occurred until water entered the control room. The reversal extended beyond individual psychology to strategic calculations. Naval warfare is ultimately mathematics: probability of detection, probability of successful attack, probability of escape, probability of completing mission objectives. When the probability of sudden destruction rose significantly, commanders became more conservative in risk acceptance. This conservatism manifested in measurably fewer torpedo attacks against convoys, shorter patrol durations, and increased abort rates. Submarines that survived their first few patrols learned caution. That caution reduced effectiveness even when attacks were attempted. By winter 1944 through 45, the Atlantic's most decisive sound was often a single, short report, followed by silence. That silence marked not the absence of combat, but the presence of a weapon that killed without warning. The hunters had become the hunted. A staff officer totaled columns in a blue-backed report: attacks, kills, expenditures, costs. The final accounting of the Atlantic campaign filled dozens of volumes, but certain numbers stood out with particular clarity. Wartime improvisation gave way to audited totals. Analysis attributed a substantial share of confirmed U-boat losses to Hedgehog and its descendants when attacks were prosecuted with continuous sonar contact. Post-war tallies listed hundreds of U-boats destroyed by forward-throwing contact-fused weapons. Of 781 German U-boats lost during the war, analysis credited forward-throwing mortars with substantial contribution to nearly 250 sinkings, either as primary weapons or in combination with other systems. Average salvos per kill were calculated at fewer than 5, far below depth charge averages, which often exceeded 20 patterns per confirmed sinking. Cost per sinking using Hedgehog was estimated at approximately £5,000, compared to over £60,000 for depth charge-only engagements. These figures included ammunition, fuel for extended searches, and ship time. Convoy survivability metrics told the strategic story. In 1942, convoy arrival rates in Britain averaged 88%, meaning 12 of every 100 ships sailing were lost. By late 1944, arrival rates exceeded 98%. This 4-ship improvement per 100 represented millions of tons of cargo delivered: food, fuel, ammunition, aircraft, vehicles, and troops. The analysis also identified limitations within which the weapon operated. Environmental thermal layers could complicate contact solutions. Heavy sea states could spread patterns beyond optimal density. Direct hits were still required, there was no proximity fusing. Yet within these constraints, the weapon's efficiency remained robust and measurably superior to preceding systems. The strategic result, restored convoy throughput and sustained decline in merchant losses, underpinned the logistics that fed Allied theaters worldwide. Without secure Atlantic sea lanes, the invasion of Normandy would have been impossible. The Mediterranean campaigns depended on Gibraltar and Malta receiving supplies. The buildup in Britain for strategic bombing required ships arriving safely. One Admiralty summary from 1946 captured the assessment. Precision ahead-throwing ordnance, integrated with continuous contact systems, materially increased the rate of submarine destruction and shortened engagement timelines by factors measured in minutes per contact. Another statistical finding stood out: days saved per voyage. With reduced submarine threat, convoys could sail more direct routes, maintain higher speeds, and spend less time zigzagging. The average Atlantic crossing time decreased from 16 days to 13 days between 1942 and 1944. This time compression multiplied effective shipping capacity without building additional vessels. Victory at sea was counted not just in boats sunk, but in cargo delivered, soldiers landed, and missions supplied. The quiet weapon had helped reopen the Atlantic lifeline that sustained Allied operations across Europe, North Africa, and beyond. A dockside photograph captured a newer triple-barrel mortar called Squid mounted on a frigate's forecastle. The caption noted range and warhead weight increases over the original Hedgehog design. Hedgehog proved the fundamental principle. Continuous sensor contact combined with contact-fused forward-thrown weapons delivered superior results to area bombardment with preset depth charges. Successors extended the concept. Squid, developed in late war years and deployed widely post-war, featured 3 large mortars firing stabilized projectiles in a triangular pattern. The range extended to 400 yards. Projectile weight increased to 300 pounds, including warhead. The system incorporated automatic firing computers that calculated lead angles based on sonar tracking data. But the core concept remained unchanged: contact fusing and forward throw to maintain sonar lock throughout the engagement. Limbo, the post-war evolution, added stabilized platforms for operation in heavy seas, automated loading systems, and integration with more sophisticated sonar suites. Yet Limbo still fired ahead of the ship and relied on contact detonation. Post-war reviews from senior officers underlined the conceptual shift the weapons represented. Victory owed more to the alignment of sensor and weapon than to raw explosive power. Vice Admiral Sir John Tovey, reviewing the Atlantic campaign, captured the lesson plainly. Success came from the silence of Hedgehog's aim rather than noise. Navy's worldwide codified integrated anti-submarine warfare doctrine after 1945. The components were radar and HFDF for interception, sonar for attack solutions, ahead-throwing mortars for lethal engagement, and air anti-submarine warfare to deny surface stalking. Each element was necessary. Together they were sufficient. The lesson outlived the war and influenced weapons development for decades. Engineering that aligns sensing with strike timing changes campaign arithmetic fundamentally. In later decades, rocket-propelled torpedoes, ships with towed sonar arrays, and helicopters with dipping sonar all inherited the Hedgehog premise. Maintain sensor contact through the attack, don't blind yourself with your own weapon. A post-war doctrinal note summarized the evolution. From area bombardment to precise engagement. From after-throw to ahead-throw, from guess to measure. The technology itself aged and was eventually superseded by homing torpedoes and other systems. But the principle endured in every modern anti-submarine warfare system. Know where the target is, keep knowing throughout the engagement, and strike without creating sensor blackout. Of the total German U-boats lost during World War II, a large fraction fell to anti-submarine warfare systems built on Hedgehog's contact-fused, ahead-throwing logic. The exact attribution is complex. Many sinkings involved multiple weapon systems. Depth charges finished what Hedgehog started. Air attacks forced submarines under where surface escorts waited. But the statistical evidence was clear. After Hedgehog entered widespread service in 1943, submarine loss rates increased and remained high through the war's end. The weapon that killed in silence helped reopen the Atlantic lifeline. In the calculus of war, where logistics determine outcomes and sea control enables everything else, that quiet innovation proved strategically decisive. Engineers at Woolwich Arsenal, testing projectiles against steel plates, could not have foreseen the full impact of their work. But history recorded the result. 24 spigots in a circular crown, firing ahead into the dark water, ending the warning and turning the tide. The Hedgehog anti-submarine mortar represents a case study in how technical innovation aligned with operational doctrine changes campaign outcomes. Between 1942 and 1945, this weapon system contributed measurably to Allied victory in the Atlantic, not through revolutionary firepower, but through evolutionary improvement in kill probability per engagement. The lessons remain relevant. Synchronize sensors with weapons, value precision over volume, measure effectiveness objectively, adapt doctrine to technology, and train systematically. These principles transcend specific platforms and eras. If you value history told through verified documents, statistics, and primary sources, consider supporting this channel. It helps fund deeper archival research and accurate, fact-driven historical narratives. What is your perspective on this part of history? Share your thoughts in the comments, because every memory and reflection helps keep the past alive.